Question 22. Find the global maximum and minimum values of y equals x cubed minus 6x squared plus 8, where x is greater than or equal to negative 1 and less than or equal to 7. The first step is to determine the function values at the interval endpoints. That is, the values of the function where x equals negative 1 and x equals 7. So substituting negative 1 for x into the equation, we get f of negative 1 is equal to negative 1 cubed minus 6 times negative 1 squared plus 8, which equals 1. Substituting x equals 7 into the equation, we get f of 7 is equal to 7 cubed minus 6 times 7 squared plus 8, which equals 57. The next step is to find the stationary points, and we do that by finding the first derivative, that is y dash, and then solve it for x, where y dash is equal to 0. So the first derivative of x cubed minus 6x squared plus 8 is 3x squared minus 12x, and we're going to form an equation, 3x squared minus 12x equals 0, and solve this for x. Dividing all terms by 3, we get x squared minus 4x equals 0, and then factorising out x on the left-hand side, we get x times x minus 4 is equal to 0. So stationary points exist at x equals 0 and x equals 4. The next step is to find the function values at the stationary points. So substituting x equals 0 into the equation, we get f of 0 is equal to 0 cubed minus 6 times 0 squared plus 8, which equals 8. And f of 4 is equal to 4 cubed minus 6 times 4 squared plus 8, which equals negative 24. So the four values that we've just found is 1, 57, 8, and negative 24. So the global minimum is the smallest of these four numbers, which is negative 24, and the global maximum is the greatest of these four numbers, which is 57. So therefore, the global minimum is negative 24 and the global maximum is 57 in the interval x greater than or equal to negative 1 and less than or equal to 7.